For generations of Chinese families, education followed a clear formula. Study hard, survive the Gaokao, enter the best university possible, earn a respected degree, find a stable white-collar job, then use that job to build a secure life. The degree was more than a qualification, it was a promise, but today that promise is being questioned. Across China, a growing number of young people are paying less attention to the name printed on a diploma and more attention to a much simpler question. What can I actually do? Can I program an industrial robot? Can I operate advanced manufacturing equipment? Can I use artificial intelligence to analyze data? Can I edit commercial video, run an online store, repair an electric vehicle, design a digital product, or care for an aging population? This does not mean Chinese students have suddenly stopped wanting university degrees. In fact, China's higher education enrollment rate is above 60%, and the country expects around 12.7 million college graduates in 2026, another record. The real change is more subtle and more important. Chinese students are not necessarily choosing skills instead of degrees. Increasingly, they are choosing skills over degrees as the main source of employment value. A diploma may open the first door, but practical ability determines whether the door leads anywhere. Why is this happening? Why are vocational programs, industry certificates, technical competitions, internships, AI boot camps, and hands-on training becoming more attractive? What kinds of skills are students choosing? And what does this shift mean for China's economy, its universities, and the future of work? To understand the answer, we first need to understand why the old degree formula worked so well, and why it is now under pressure. For much of modern Chinese history, university admission was genuinely rare. A degree separated a relatively small group of graduates from a huge labor force. It offered access to government offices, state-owned enterprises, schools, hospitals, banks, and expanding private companies. For rural and working-class families, university could transform the future of an entire household. Parents were not irrational when they treated academic education as the safest path upward. They had seen degrees produce real social mobility. This history still shapes family expectations. Many parents continue to prefer a university with a familiar name over a vocational college with excellent equipment. A child who becomes an office worker may be celebrated, while a child who becomes a technician may still have to explain the choice, even if the technician earns more. But higher education has expanded enormously. China now operates the largest education system in the world, and higher education is no longer reserved for a small elite. That is a major social achievement. Millions more people have access to knowledge, professional training, and opportunities their parents never had. However, mass higher education changes the economic meaning of a degree. When relatively few people have a credential, the credential itself is a strong signal. When millions of people graduate every year, employers need additional ways to separate candidates. They begin asking about university ranking, internships, software knowledge, project experience, professional certificates, communication ability, and real work samples. The degree does not become worthless, it becomes incomplete. This is sometimes called credential inflation. A job that once required secondary education may begin asking for a bachelor's degree. A job that once required a bachelor's may prefer a master's. Students stay in education longer, but the additional credential does not always create additional productive ability. The result is an exhausting race. One student earns a degree to stand out, the next earns a master's. Another adds overseas study. Everyone becomes more qualified on paper, but the number of attractive entry-level jobs does not automatically grow at the same speed. For many young Chinese people, the question is changing from how high can I climb in the education system to, at the end of this climb, what work will I be able to perform? The second reason behind the shift towards skills is the employment market. China expects approximately 12.7 million college graduates in 2026, about 480,000 more than in 2025. That is an extraordinary amount of talent entering the market in a single year. But the supply of traditional graduate jobs has not kept pace. As of June 2026, the official urban unemployment rate for people aged 16 to 24, excluding students, was 14.9%. That was an improvement from the previous month, but it still showed serious pressure on young job seekers. The overall urban unemployment rate was far lower. This tells us the problem is not simply a total absence of work. It is also a mismatch between the jobs young people expect, the training they have received, the locations where they live, and the skills employers need. Many graduates aim for a limited group of positions, Civil service jobs, state-owned enterprises, major internet companies, finance, education, media, management, and other white-collar professions. These jobs often provide status, stability, predictable career paths, or comfortable working conditions. Competition can be extreme. A company may receive hundreds of applications for one junior office role, while a factory struggles to recruit technicians who understand automation systems. A graduate may spend months searching for a job related to a general business degree, while an electric vehicle service center needs people who can diagnose battery systems. This creates a strange labor market picture: too many applicants and too few workers at the same time. China has a large pool of educated young people, yet industries including high-end manufacturing, artificial intelligence, modern services, semiconductors, robotics, elderly care, and green technology still report shortages of particular skills. Students can see this mismatch. They hear stories of graduates sending out 100 resumes with no result. They see master's students applying for jobs that once went to bachelor's graduates. They also see technicians, content creators, skilled service workers, and small online merchants building careers without following the most prestigious academic route. The psychological effect is powerful. A degree offers a delayed and uncertain reward. A practical skill offers faster evidence. If you learn video editing, you can produce a portfolio. If you learn programming, you can publish an application. If you learn to operate a machine, you can demonstrate competence. If you study e-commerce, you can open a small store and test whether customers buy. The feedback may be harsh, but it is visible. Skills turn employability from an abstract promise into something a student can show. The third reason is artificial intelligence. For years, parents encouraged children to avoid physical or technical work and pursue jobs in offices. But AI is becoming especially capable at the routine tasks performed by junior white-collar workers. It can summarize documents, translate basic text, draft marketing copy, produce presentation slides, write standard computer code, analyze simple spreadsheets, answer customer questions, and create images or videos. These tools do not eliminate every profession. A senior lawyer, engineer, designer, translator, or financial analyst contributes judgment, relationships, accountability, and deep experience. But young graduates do not enter a profession as senior experts. They traditionally learn by doing simpler work first. If AI automates part of that beginner-level work, the first step of the career ladder becomes narrower. This is one reason Chinese universities are rapidly changing their programs. Between 2021 and 2025, higher education institutions reportedly eliminated or suspended more than 12,000 undergraduate programs, while creating more than 10,000 new ones. Programs connected to robotics, semiconductors, embodied intelligence, digital finance, and agricultural drones are expanding. While some traditional language, arts, and management courses are being reduced or redesigned, students are adapting in the same way. A finance student learns Python. A language student adds international trade. A psychology researcher learns data analysis and AI agent tools. A designer learns motion graphics, user interface prototyping, and generative media. A mechanical student learns sensors, industrial software, and robot maintenance. In other words, students are not always leaving their academic field, they are adding a layer of executable skill. This leads to an important principle for the AI economy. Knowledge tells you what something means, skill allows you to do something with that knowledge. The strongest workers will usually need both. The fourth reason is China's industrial transformation. The old image of Chinese manufacturing was based on huge numbers of low-paid workers performing repetitive tasks. The new image is increasingly different. Automated production lines, electric vehicles, industrial robots, batteries, solar equipment, drones, high-speed rail, smart logistics, advanced materials, and precision machinery. These sectors do not simply need more labor, they need workers who can combine physical systems with digital knowledge. Consider a modern factory technician. The job may require reading technical diagrams, calibrating sensors, monitoring software, analyzing production data, identifying a mechanical problem, communicating with engineers, and maintaining expensive automated equipment. That is not unskilled factory work. It is applied technical intelligence. The same is true in many service industries. An electric vehicle technician needs knowledge of electronics and software, not only traditional mechanics. A modern nurse or eldercare worker may operate digital monitoring systems. A logistics worker may manage automated warehouses. A farmer may use drones, sensors, and data platforms. A media producer may work with AI generation, virtual cameras, and real-time editing. These are sometimes described as new-collar jobs, occupations that require significant technical skill, but do not always require the most traditional academic path. China's policy direction reflects this demand. The government has promoted large-scale vocational skills training, closer cooperation between colleges and companies, new vocational undergraduate institutions, and stronger salary incentives for skilled workers in state-owned enterprises. By 2025, China had established 63 vocational undergraduate universities within 5 years. The 2025 education statistics listed more than 500,000 students in vocational bachelor's programs and more than 17 million in higher vocational colleges. That distinction matters. Vocational education in China is no longer limited to a short secondary school track. Students can now pursue applied education at the undergraduate level, combining a recognized degree with job-specific training. This may be the clearest symbol of the entire shift. The future is not necessarily university or skills. It may be a university designed around skills. So what do Chinese students mean when they say they want practical skills? The first category is advanced industrial skill. This includes robot operation, numerical control machining, industrial automation, equipment maintenance, welding, electrical systems, battery technology, semiconductor production, drone operation, and smart manufacturing. These skills are attractive because they connect directly to industries where China has major investment and global ambitions. The training can be demanding, and working conditions vary widely, but the relationship between learning and employment is often clearer than in a general academic program. The second category is digital skill. Students are learning Python, data analysis, AI tools, cloud platforms, cybersecurity, software development, digital marketing, and product design. Importantly, not everyone wants to become a full-time programmer. An accountant may learn data automation. A marketer may learn AI video production. A factory engineer may learn machine learning for quality control. Digital skills are becoming horizontal. They sit across occupations rather than belonging to one department. The third category is commercial and entrepreneurial skill. China's enormous e-commerce and social media ecosystem has taught young people that a career does not always begin with a formal recruitment process. Some students learn live stream selling, online store operations, short video production, search optimization, customer acquisition, product photography, and supply chain management. Most will not become celebrity influencers or wealthy founders, but these skills can still lead to jobs with brands, agencies, local businesses, and platform merchants. The fourth category is skilled personal service. This includes healthcare support, elderly care, childcare, rehabilitation, beauty services, nutrition, fitness, hospitality, and pet care. As China's population ages and consumer expectations rise, many of these occupations require greater professionalism and technical knowledge. The fifth category is creative production. Young people are learning video editing, animation, sound design, game production, 3D modeling, user interface design, and AI-assisted content creation. The creative market is highly competitive, but a strong portfolio can sometimes communicate ability more effectively than the title of a degree. And the sixth category may be the most important: transferable human skills. Employers still need people who can communicate, solve unfamiliar problems, work in teams, manage clients, learn quickly, and take responsibility for results. Technical tools change. A person who knows how to learn can change with them. Shift towards skills is also changing where education happens. One route is the vocational college, especially programs connected closely to local employers. The strongest programs combine classrooms with laboratories, factory equipment, internships, and instructors who understand current industry practice. Another route is the applied university. These institutions may still award bachelor's degrees, but they place greater emphasis on engineering practice, projects, and employer partnerships. A third route is short-form training, AI boot camps, coding courses, professional certificates, technical academies, and online programs. These can help a student test a new field without committing several years. A fourth route is competition. China has a large culture of skills contests, programming competitions, robotics events, e-commerce challenges, and innovation projects. A strong result gives students evidence that can be shown to an employer. A fifth route is the internship or apprenticeship. This can be more valuable than another classroom course when students are given real tasks and meaningful supervision. It teaches not only technical ability, but also deadlines, quality standards, communication, and workplace discipline. A sixth route is self-directed online learning. A student can watch tutorials, use open-source software, practice with AI, join a technical community, and publish work online. The cost can be low, but the student must create structure and avoid the illusion that watching a lesson is the same as mastering a skill. The common feature across these routes is proof. A traditional course often ends with a grade. Skills training should end with evidence. A repaired system, a working application, a finished design, a successful sale, a machine that operates correctly, or a problem that has been solved. Students do not make these choices alone. In China, education decisions often involve the entire family. For many parents, vocational education has carried a stigma. It was sometimes seen as the route for students who had failed academically rather than a positive choice for people with practical talent. That perception will not disappear quickly. Quality also varies. Some vocational institutions have excellent equipment and strong employer partnerships. Others may teach outdated content, provide weak career guidance, or advertise employment outcomes that are difficult to verify. But parents respond to results. If a neighbor's university-educated child remains unemployed while a trained technician receives several job offers, attitudes begin to change. If skilled occupations receive clearer promotion systems and better pay, the social status of those jobs can rise. If vocational bachelor's degrees allow students to combine credentials with practical training, families may see less risk. Wage trends also attract attention. Recent research has suggested that earnings for some blue-collar categories have grown faster than for white-collar workers, although averages hide major differences in location, hours, safety, benefits, and job security. A delivery driver earning more than a junior office worker does not automatically have a better career. Physical risk, long hours, weak social protection, and limited progression still matter. Skilled trades should not be romanticized simply because graduate employment is difficult. The real change is not that every manual job is suddenly desirable. It is that families are beginning to distinguish between low-skilled labor and high-skilled technical work. The skills-first movement has real advantages, but it also contains risks. The first risk is training for a skill that becomes obsolete. A narrow software tool may disappear. A popular platform may change its rules. A machine may be replaced. A certificate that employers respect today may mean very little in 5 years. This is why practical education still needs theory. A student who memorizes one machine may struggle when the equipment changes. A student who understands electronics, mechanics, data, and problem-solving can adapt. The second risk is low-quality training. Whenever students are anxious about employment, businesses appear promising a shortcut. Some boot camps charge high fees for basic material available free online. Some certificates have little labor market value. Some institutions exaggerate salaries or job placement rates. Students should ask, do employers recognize this qualification? Can I speak to former students? Will I complete real projects? Who teaches the course? Is the equipment current? What percentage of graduates work in the field 6 months later? The third risk is inequality. Wealthier students may obtain both a prestigious degree and expensive practical experience. They can afford unpaid internships, international programs, better equipment, and time to build a portfolio. Poorer students may be pushed into narrow training because they need income quickly. A fair skills-based system must create genuine mobility, not simply give different social classes different kinds of education. The fourth risk is removing the degree too soon. Formal credentials remain important in China. Government recruitment, public institutions, regulated professions, management tracks, and many large employers still use degree requirements. A degree also provides broader knowledge, social networks, and time for intellectual development. The message should not be degrees are useless. It should be, a degree without ability is fragile, while ability supported by broad knowledge is powerful. The fifth risk is turning education into job training only. Universities are not factories for producing employees. History, philosophy, literature, pure science, and the arts create cultural and intellectual value, even when they do not map neatly to one vacancy. Society still needs citizens who can think critically about technology, power, ethics, and human meaning. The challenge is to protect broad education while connecting it more honestly to the world students will enter. If students are choosing skills over credentials, universities will have to change. They will need more project-based learning, stronger career guidance, instructors with current industry experience, laboratories that reflect modern workplaces, and partnerships that provide meaningful training instead of symbolic internships. They may also need more flexible credentials. Rather than asking students to complete one fixed program and then leave, institutions could offer smaller modules throughout a person's career. AI for finance, automation for manufacturing, digital tools for healthcare, or management for technicians. Employers must change too. Companies often complain that graduates lack practical ability while continuing to filter candidates mainly by university name and degree level. If employers truly want skills, they should use work samples, technical assessments, paid apprenticeships, and skills-based promotion systems. They should also invest in training. It is unrealistic to demand that schools produce workers who already understand every company-specific tool. Businesses benefit from skilled employees and must share the cost of developing them. For China's economy, the opportunity is enormous. Better alignment between education and work could reduce youth unemployment, raise productivity, support advanced manufacturing, and give young people more varied routes to a good life. But success cannot be measured only by how quickly a graduate accepts a job. Job quality matters. Pay, safety, working hours, benefits, dignity, career progression, and the ability to continue learning. So why are more Chinese students picking skills over degrees? Because a university credential is no longer rare enough to guarantee a good job. Because a record number of graduates is competing for a limited supply of traditional white-collar positions. Because artificial intelligence is automating some of the entry-level tasks that graduates once used to begin their careers. Because China's expanding industries need technicians, operators, developers, designers, healthcare workers, and hybrid professionals who can connect knowledge to action. And because a practical skill offers something a diploma alone cannot, visible evidence of value. But the most successful students will probably not choose one side of a false competition. The future does not belong only to the person with the highest degree. It does not belong only to the person with the fastest technical certificate. It belongs to people who combine knowledge, practical ability, judgment, communication, and the capacity to keep learning. For one student, that may mean a vocational bachelor's degree in smart manufacturing. For another, it may mean studying finance while learning Python and AI. For another, it may mean becoming an electric vehicle technician and later moving into workshop management. For another, it may mean using design education to build a portfolio in digital media. The path is becoming less uniform. That may be uncomfortable for families raised on one definition of success, but it may also be liberating. A young person should not be judged only by the prestige of the institution they entered at 18. They should be judged by what they can build, repair, understand, improve, and contribute over an entire lifetime. China's shift towards skills is therefore not the death of the degree. It is the end of the degree as a complete answer. The diploma still matters, but the new question is unavoidable. What can you do with it? If you enjoyed this video, subscribe for more stories about education, technology, and the changing global economy. And let me know in the comments, if you were starting your education again today, would you choose a prestigious degree, a practical skill, or a combination of both? Thanks for watching, and I'll see you in the next video.